Welcome to our next measurement video, which is on volume. So today we're going to be looking at what volume is, and I'm going to look through some examples of how to calculate volume. All right, so what is volume? So volume, as we see here, is the volume of a three-dimensional object is the amount of space it occupies. This space is measured in cubic units. Okay, so if we have a look at the units, at these three cubes there, you'll see they're different sizes. If we think of looking at the sizes, this one here could be 1 millimeter by 1 millimeter by 1 millimeter. And we've got the next one up, which is 1 centimeter by 1 centimeter by 1 centimeter. Then we go to our larger one, which we can represent as 1 meter by 1 meter by 1 meter. So as we get larger, the amount of cubic units increases, and we'll look at how we can actually convert between those different units as well on this slide here. So if we have a look at converting, what we're looking at when we're going from a smaller unit to a large unit, we need to divide. Now if we have a look at the factor, if we look at millimeters and centimeters, how many millimeters are in a centimeter? Well, there are 10 millimeters in a centimeter. So if we look at the factor, we divide by 1,000, and that's actually 10, which is the factor, to the power of 3. And if we have a look at how many centimeters there are in a meter, there's 100. If we have a look at that factor there, that's 100 to the power of 3. So the scale factor is cubed. All right, and we may have noticed in the squared, in our area topic, the factor is actually squared if you go back and have a look at that. So, but we can use this table as a little bit of an example. Basically, millimeters to centimeters cubed, divide by 1,000, centimeters cubed to meters cubed, we're going to divide by a million. So we're going to have some really large numbers here coming down to a small number. Conversely, going the other way, if we go this way, we can see that we're multiplying by a million and then multiplying by 1,000. All right, so when we look at a rectangular prism, so the volume of a prism, we're looking at the volume, the amount of shape, the amount of area it occupies, sorry, I should say, the amount of space it occupies. And the formula for a rectangular prism, as we've probably known, is length times width times height. So if we think of this box, so to speak, we can calculate its volume using its dimensions. So we can see the dimensions there. So we'll just do a quick calculation here of the box, and if we use our formula, we go volume equals length times width times height. So that volume equals, the length is 50 times 37 times 16. And if we put that all into our calculator, we get 29,600 millimeters cubed. So make sure we're getting that unit correct, millimeters cubed now. So if we think of cubic units, we think of cubes. All right, so if we have a look at other prisms, now we can get different shaped prisms. That was a rectangular prism, and length times width, if you look at the formula of length times width times height, length times width is actually the area of the end, or a base. And if you have a look at some of these examples here of other prisms, you will see that the other prisms basically have two identical end faces, and they're connected by straight edges. So you can see this triangular prism, see this composite prism, and the cylinder here all have exactly the same identical end faces connected by straight edges, and they are actually solids with uniform cross section. So if you imagine we were to cut slices through this prism, even through the cylinder, the slices would be exactly the same. They would have a uniform cross section, and what you would see is you'd see a triangular shape as that would be cut. So a simple formula, going back to the length times width, is that the area, the volume of a prism is the area of the end multiplied by the length or the height. If you want to use height, that doesn't really matter. So all we need to do is calculate the area of the end and multiply that by the height. So we'll have a look at a couple of examples. So here we're looking at finding the volume of the following triangular prism. Now if we have a look here, we've got this face here and this back face here are identical, and they're joined by two straight edges. So we can use that formula there. So the volume here equals the area of the base. So we're going to write the formula out. Area of base, excuse my writing, multiplied by the height. So that equals the area of the base, now equals, base times height divided by 2, because we've got a triangle, which equals 3 times 6 divided by 2, which equals 18 divided by 2, which equals 9 meters squared. That's the area of the base. Now the volume, if we multiply that 9 by the height, or the length there, 4, gives us 36 meters cubed. So the volume of that prism is 36 meters cubed, or cubic meters, as have been said. Okay, one last one we'll look at here is we're going to look at the a rainwater tank with a radius of 2 meters, and we're going to have a look at with a vertical height of 4.5 meters. So we're going to calculate the volume of that tank. So if we have a look here, we can draw a diagram. If we've got a tank here, and we know that the radius is 2 meters and the height is 4.5 meters. So what we're looking now to say, so the volume of this is the area of the base times by the height. So the area of the base equals pi times the radius squared, which equals pi times 2 squared, which equals pi times 4, which equals, if we go to our calculator, pi times 4 equals 12.57 meters squared. So the volume now equals 12.57 multiplied by 4.5. Go to my calculator, 12.57 multiplied by 4.5 equals 56.57 meters cubed. All right, so we've taken the information out of the question and found the answer. Okay, thanks for watching. We'll see you next time.